Alright guys, today we're going to start on section 4.1. Part of this is review with a little bit of new stuff added to it. Let me see if I can get this to focus just a little bit better here. Alright, we're going to start out with vertex form for a quadratic function. This should be review. This was in chapter 2 when we talked about common functions. Okay, and what I need you to remember here is that your A, that tells you which direction this is going to open. It's going to open up if A is greater than 1. It's going to open upside down if A is less than 1. The other thing that A tells you is whether it's, how wide it's going to be, whether it's going to be normal or wide or skinny. And remember, there's special vocabulary that goes with that. So again, when we're talking about that A, we're going to ignore the negative. So your book says just take the absolute value of A. And if the absolute value of A is bigger than 1, that is called a stretch, which means it's going to be tall and skinny. If the absolute value of A is smaller than 1 but bigger than 0, that is called a compression, or you can say the graph is compressed, and that means that it is wide. The other things that we should be able to get from vertex form is what the vertex is. And remember, that's the turnaround point of this parabola. So your vertex is h, comma, k. And see, this is a positive h, so we're taking the opposite of the sign inside, the same as the sign outside. Remember, your h goes left and right, and you're doing the opposite of that sign, from the original vertex form. And the k, that is your up and down shift, and you're going to do the same as that sign. So now, here's our first example. And again, part of this is going to be review. Part of it is going to be new that we're going to add to it, and we're going to add some new vocabulary as we go. So we have the example, y equals 3 times x plus 4 squared minus 1. Well, the first thing we've got to do is we've got to find the vertex, which is not new. We're going to do the opposite of this number, so that's a negative 4. The same as this number, that is negative 1. That is your vertex. So, negative 4, 1, 2, 3, 4, negative 1, there's my vertex. Because this is a positive 3, I know that it is going to open up. Okay? The next thing that is a new term for us, that is the axis of symmetry. And down here I've told you I've abbreviated it as AOS. Axis of symmetry, that is a vertical line that goes through the vertex. Okay, and that equation always looks like x equals some number. So I'm going to go ahead and sketch in my parabola. We'll draw in the axis of symmetry and then talk about the equation for that. You zoom out just a little bit. Part of this is behind my box. There we go. So when I sketch this in, here's my vertex. It opens up, and it should be fairly skinny. And the reason it should be fairly skinny is because my A value is greater than 1. Okay, it opens up because A is positive. It is skinny because it is greater than 1. So now, my axis of symmetry, it is this vertical line that passes through the vertex. So the equation for that vertical line is going to be x equals, and the axis of symmetry touches the x-axis at -4. If you'll notice, that comes straight out of our vertex here. So your axis of symmetry is always the x part of your vertex. So now, the maximum and minimum value. This is where we've got to go back to something we did the very, very first week, just a little bit, okay? What I want to do is I want to look at this parabola and see, does it have a low point? Okay, when we're talking about our y values, does it have a low point where that is the lowest or the smallest y value I can have? Or does it have a high point that is the highest y value I can ever have? Well, because this is opening upward, it is going to continue upward forever, so it does not have a maximum. The lowest point on my graph is right here. So it has a minimum value, and the minimum value is always the y part of the vertex because that's as low as it goes. And that y part right there, the lowest it goes is -1. Y part of the vertex is -1. So my minimum value is -1. Now, when we talk about domain and range, remember, domain is all of your x values. Okay, and this again goes back to stuff we did, right there at the very, very beginning. Your x values run left and right. Well, as this parabola opens upward, it is continuing to get wider and wider. Mine is sketched by me. It's not perfect, so it may not look quite like it gets wider, but we can put it on our graphing calculator. Except I'm doing this at home and I don't have mine loaded on my laptop at home. So you're going to have to take my word for it. As it goes upward, it continues to get wider and wider. So how far to the left and how far to the right is this graph eventually going to go if it continues upward forever? Well, to the left, it's going to go all the way to -infinity. To the right, it will go all the way to +infinity. And that is our interval notation. It starts at -infinity on the left, and it will go all the way to +infinity on the right. Your range, these are your y values. So I want to start with how low it goes to how high it goes. Well, your lowest y value is -1. It's going to get a bracket because it actually touches y is -1. And then this graph continues upward forever, so it's going to go all the way up to +infinity. All right, for the next example. Okay, we're going to start with the vertex. We're going to do the opposite of this number, the same of the number outside. So my vertex is 4, -2. I know because this is positive, it's going to open up like this. Because that number is larger than 1, it's going to be skinny. So now, if I go ahead and sketch this, 4, -2, opening up and kind of skinny. There we go. Draw in your axis of symmetry. Remember, it is this vertical line that goes through the vertex. That equation is going to be x equals the x part of your vertex. The minimum value is the lowest y value on the graph. It's also the y part of your vertex. I know it has a minimum because it's opening upward, and this is the lowest part of the graph. So my minimum value is -2. The domain, once again, as this opens upward, it is continuing to get wider. So as it goes up forever, it's going to continue to get wider forever. So the domain is negative infinity to positive infinity again. And here's a hint. All of the parabolas that open up or down are going to have the same domain. The domain for every quadratic function that opens up or opens down will always be negative infinity to positive infinity. The range you've got to take a better look at. You want to pick your lowest y value, which this time is negative 2. Your highest y value, it's going to go up forever to positive infinity. So a bracket, negative 2, positive infinity. Okay. All right, we got one more. It's just like that. So what I want you to do is I want you to pause the video for just a second. See if you can do this one on your own. After you've completed, your sketch and you've answered the questions, then I want you to look back at mine, restart the video and check it and see how you did. So now, because this is negative, I know it's going to open upside down. Then, if I take the absolute value of negative 2, I get 2, which is bigger than 1, so it's again going to be kind of skinny. So for my vertex, I take the opposite and the same. So my vertex is 1, negative 3. Opening down and kind of skinny. Looks a little bit like this. Draw in my axis of symmetry. So that is x equals positive 1. That's where it touched the x-axis. It's also the x part of my vertex. Maximum or minimum? Well, this one is going to continue down forever, so it doesn't have a low point. But it does have a high point. It's not going to go any higher than right here. So it is going to have a maximum value, and your maximum value is always the y part of the vertex. So that is negative 3. So once again, this is a parabola that opens down. And I just told you that every parabola, every quadratic function that opens up or down is going to have the same domain. Negative infinity to positive infinity. Your range this time, what is your lowest y value? Well, it continues down forever. So my lowest y value is negative infinity. The highest y value is right here. It is negative 3. Alright, so for the next problem, this is an application of quadratic functions, okay? This picture below shows the jump of a dolphin. And if you notice, when a dolphin comes up out of the water, it goes up and it goes back down. It's in the shape of a parabola. So what they want to know is what is the quadratic function that is, that models this dolphin's jump. Okay, so what I want to do is I want to take and I want to write an equation in the form y equals a times x minus h squared plus k. So now, there are 3 things that I need to know to write this equation correctly. I need to know the a value, and I need to know the vertex. Okay? The vertex is easy enough to get. If I go right here, this is my vertex. The vertex is 3, 7. So I'm going to go ahead and plug that in. So I've got y equals a times x minus, now my h value is a 3, squared, plus my k value is a 7. So all I have to do now is figure out what my a value is. Well, I know a is going to be negative because this is a parabola that opens upside down. But I don't know what that a value is. So here's what we've got to do. We've got to pick another point on this graph where it touches an ordered pair where the x and the y are both whole numbers. Okay, and this is a little bit difficult to see, but right here at 9, 4, that is another ordered pair where your x and y are both whole numbers that the graph touches. Okay, almost looks like 8, 5, but it's just really, really close. When I actually look in the textbook, it's much more clear. When I copied and pasted the picture, it's just not quite as sharp. So 9, 4 is the other point. So what you're going to do is you're going to plug these values in for x and y in this equation so that you can solve for a. So my y is 4. That is equal to a times x minus 3 squared plus, oh, I got to plug my x in, I forgot. Let's go back. My x was a 9, so I'm going to put a 9 right there where the x is. And then put my 7 back here. Okay? So you can see I took out my x and my y, and I put these values for this other ordered pair there. So when I start simplifying this, I'm going to have 4 equals a times 9 minus 3 is 6 squared plus 7. So now 6 squared is 36, so this is 36a plus 7. Now I've got to solve for a. Subtract 7 from both sides, and I get negative 3 equals 36a. Now divide both sides by 36 and reduce. So a is equal to negative 1/12. So my equation will be y equals negative 1/12 times x minus 3 squared plus 7. That is the equation for this parabola modeled by the dolphin jumping out of the water and back in. Okay, so here is another one where they're just asking you to change just one thing about this graph. Okay, it says suppose the path of the jump changes so that the axis of symmetry becomes x equals 2 and the height stays the same. If the path of the jump also passes through the point 5, 5, what quadratic function would model this path? Well, before we can get into that, let's go back here just a second to this last problem. Okay? In this one, my axis of symmetry is here, and that equation is x equals 3. That's the x part of my vertex. So for the new problem I've got down here, the x part of my vertex is going to be a 2 because we're changing the axis of symmetry to x equals 2. But the height of the jump stays the same. Well, how high does this go? Well, it goes all the way up to 7. So my new vertex is 2, 7. But then it also goes through the point 5, 5. So I'm going to take my equation, y equals a times x minus h squared plus k. I'm going to plug in my vertex, and I'm also going to plug in the ordered pair 5, 5 for my x and my y. So let's plug all of that in. So y is 5 equals a times my x is 5 minus my h value is 2 squared plus my k value is 7. And now I can solve this equation for a. So 5 minus 2 is 3 squared. So I end up with 5 equals 9a plus 7. I have to subtract 7 from both sides. So that will give me negative 2 equals 9a. Divide both sides by 9, and a is negative 2/9. So the new equation this time is going to be y equals, plug in your a value, put your vertex in, and this is the equation of the second jump they've described. All right, that is all for section 4.1.